there's four of us, but
Four of us? Okay, sorry. Alrighty, so today we're going to finish up this lecture that I thought would only take me one lecture. Pick up right where we left off. Actually, no, we're not going to do that. I want to say to anyone who can hear me, okay, if you want an account with the U and you don't have one, or I haven't got you set up with that yet, contact me, because there's a lot of people and I've gotten everybody mixed up. So I got to say that first. Okay. So anyway, continuing where we left off from last lecture, we want to talk about file permissions. Now, Linux was designed from the ground up, well, because it's based on Unix, and Unix was designed this way too, to be a multi-user system. So multiple people could be using a computer at any given moment, which is different from the Windows personal computer idea. But it has a very sophisticated file permission system. And so that file permission system basically tells you what you can and can't do with certain files or certain directories. So let's start off with a demonstration. So I actually created a different user to kind of demonstrate what's going on here a little better. But we can do a list. Maybe we'll make a file here. And maybe another file. Okay. So this is my home folder. I made a completely separate user. You notice I'm not logged in now as Mint admin. I'm logged in as Oz, which is a nickname I got in high school and I still use for my usernames. So if we do ls, it tells us what the files are. And I showed you last time, actually, let's do this so I can blow this up a little bigger. Huh? Whoa. That was not what I was expecting. Let's just do that. Now, can everyone see that better? Okay. So we do an ls, tells us we've got all these folders. We've got a Fido and a foobar. And then I showed you the L flag last time. Stands for long, and it lists a lot more information about the files. Now over on the left here we have what are called the file permissions. And this is it's not immediately obvious what it's telling us, but the very first D here, that stands for directory. Okay, so anytime there's a directory, or the file is a directory, because remember everything in Linux is a file, that D is going to be there. And so you'll notice on the Fido and foobar that we just have a dash, because those are not directories. Okay, then the first three flags here are the permissions that you have on this file. Okay, so these are your permissions on this file. Or I should say the owner's permissions on this file. The second triple is the group. Okay, so every file has an owner and a group owner. And so these are the permissions for the owner. These are the permissions for the group, this next three here. And then these are the permissions for everyone else. Okay, so right now, and you notice these three, we have a R and W, and then some of them have an X. And so the R stands for read. Do you have permission to read this? W stands for write. Do you have permission to write to this file? And X stands for execute. Do you have permission to execute this file if it is executable? So you'll notice then, I don't actually know what this number is. So I guess it's not that important. But then we have the owner. The owner in this case is Oz, or me. I just barely set this user up. The group is Oz. So every user has their own personal group that they are a part of. Okay, you can be a part of multiple groups. And in fact, on the CHPC cluster, we will all be part of the MAE or USU MAE 6930 group. Okay, so that way they know who we are. The next is just the number of, I believe, kilobytes. It's either bytes or kilobytes that the file is, and then the last time that file was modified. Okay, so as far as permissions go, now just to show you, I'm going to go back up. You'll notice we now have a Mint admin and an Oz home folders. Okay, so if I were to list the permissions on these, okay, so it says Mint admin has read, write, and execute permissions on the Mint admin. Okay, you'll see the difference there between those two. And everyone else, which would be me in this case, has a read and execute. Now in a folder, execute means you can actually CD into that directory. That's what executing a folder means, is you can go into it. So I can CD into Mint admin, and we can list, there's my old hello folder there. And if we look at this, you'll notice that I have read access to hello, but not write access, if we look at these last three. So if I were to open up hello, you'll notice Vim, the text editor, is telling me that I have read-only access to this. And if I were to try and write, it would say, warning, changing a read-only file. Okay, and if I try and write it, it won't let me. And so it tells me I can add the exclamation point. Now, so Vim was warning me this is read-only. When I tried to put some text in there, it said you shouldn't be doing this because it's read-only. And then I forced it to try and write the file, and now the operating system stopped me because I do not have permission to write to this file or to change it. So that's kind of the permission system. And if we go back here, so we can change permissions. All right, and we can do that with the chmod. CH stands for change, I believe. Mod stands for modify or something like that. But it's pretty simple. You can modify the permissions for anything you have write access to, I believe. I'm not an expert on this because I don't use it very often. But if we go back to my home directory, I can, let's just list these first. So let's do chmod, and then you put in the permissions that you want to change, okay? So these right here. So in order to do that, there's U stands for user. So user minus R stands for take the read permission off of the user. Okay. A G stands for group. So you notice they all have read access. So if we wanted to do all, and we wanted to take write permissions off of Fido for everyone else, or read, sorry. When you type this again, you'll notice, okay, so I actually got that flag wrong. That actually all took read permissions off for everybody. So
you can't read it.
So I can't even read it now. But I own it, so I can still change the permissions on it. So I can do.
So what happens if you try and open it?
Okay, well, we'll see. Permission denied. Okay. So, I'm going to say give the user read permissions, and now it lets me open it. Okay. So actually, let's just look at the man page here. A combination of the letters UGO. O is what I wanted. O stands for other. If you look here, it explains that. So, whoops, I forgot the file. Okay. Alrighty. So now you can see we have sort of what I wanted, which was anyone in the group now cannot modify this file, but anyone else outside the group can, which is kind of ridiculous. Okay. There are ridiculous permission settings. Generally, the defaults are okay, but you may run into permissions issues. So I wanted you to be aware of this. There's another command, chown, change the owner. Okay, you generally have to have admin privileges to do this, which you generally will only have on your own computer. But you can change the owner. You can change the group that owns it. Okay. So anyway, let's directory permissions. Sort of the X means execute if it's an executable kind of program file, or for directory means can you actually go into it. The next thing I wanted to talk about was sudo. So, su stands for the super user. Every computer, every Linux machine has a root user. Okay, and root user can do whatever the heck they want. Okay, and generally to get to the root user, you have to do the following command, which is, and then it asks me for a password, and I don't actually have a password because I'm not part of the sudo group. This user is not an admin. So we can switch users and log in now as the Mint admin. Whoa. Okay, that's a little too big, huh? Oh, come on, really? There we go. Okay. So if I do that, it's going to ask me for the password. Okay, and now I am in super user mode. I am now in the root. I am the root user, which means I can do anything I want. I can delete the Oz guy. I can delete his entire home folder because I am God, basically, at this point. So this is actually a really bad thing to do. Okay, you can screw yourself over this way. So what you can do instead, the sudo command, what it does is it gives you root privileges for a single command. So this is useful mostly when you are trying to install new programs. Okay, so app-get is the installer, but in order to install programs, you usually have to be the root user. So this allows you to have sudo powers or super user powers, but in a limited fashion, only for this one command. Okay, so that's basically what that does. Okay, let's go to the next slide. Okay, so this is just some little things that'll get you started. So there are quite a few manipulation commands, okay? CAT stands for concatenate or something. It takes the file and displays it on the screen for you. And since there's nothing in hello, it's not going to display anything until we put something in it. Okay, so now it displays that. And that can be useful because you can actually put commands into a file and save them for later. And then you can use cat to pull them back out of the file and use them. That's why that's useful. And we'll get to that in a little bit. WC stands for word count. It's kind of fun. It gives you information about the file. If you want to see how many lines there are, has one line. Just kind of fun little tool if you want to know how much you've typed. And then the big one is grep. Okay, grep is like the best tool ever. Grep, I don't actually know what it stands for. But what it does is it will search through all the files you tell it for a specific pattern. Okay, and when it finds that pattern, it will print out the result. So you can use it, especially when you're looking through your source code, to find where is this variable being used and what is it being assigned to, and all sorts of fun stuff. So the first, you type grep, you type the word that you're interested in, and then the file. I know that's a little confusing that you wanted to search through. But then it find it. Well, because I have it capitalized. So I'm going to add this. It says ignore case. And now I found it. Okay, grep takes several different flags. N will list the line number where it finds it at. I, again, is ignore case. But probably the most important one is the R flag. What does the R flag do and everything else? Recursive. It makes it scan everything. So instead of searching a specific file, I can now tell it, I just want you to look in this folder. And I think I forgot to mention that yesterday, is that a single dot stands for the current directory I am in. Okay? And so if you do that, hey look, we found a config file. I did not expect that to happen. But this config file at line 683 has the word world. However, you'll see it's actually world net. So maybe we just want world. So then we put a W in our flags here. It stands for whole word. Okay? We don't want partial matches. So now it comes up with that. Okay, so there's now grep doesn't match just words, it matches patterns, and it's similar to the globbing thing that I showed you yesterday, but this doesn't use globbing, it uses what they call regular expressions. And regular expressions are very powerful, they're very complicated, they're kind of confusing, and it can take a while to get used to them. But the basic ones you need to know are star, okay? And since I want it to just search everything, oh my. Star basically tells it, I want you to match the HEL and then anything after that, okay?
So there's one up there that only has HE. You see that?
Oh, I'm sorry. I'm sorry. In regular expressions, that is incorrect. In regular expressions, the star says match any number of the previous character. So the previous character in this case is L. So you see we actually matched hell from Adele here. Well, that rhymes. And then these other ones will just match the HEL, because the star means 0 or more extra L's. Okay.
Right. Why is there? There's one with only HE. That one.
Oh, really? Oh, because it's saying match 0 or more.
But
So 0 L's is HE.
Oh.
Does that make sense?
Oh, so it's only. Huh. So the asterisk is connected to that last character?
Yes.
Interesting.
It's because we're not doing globbing in this case. We're doing regular expressions, which is different.
I did not know that.
Globbing is performed by the terminal. Regular expressions are actually processed by the program inside. I don't know how it tells the difference, but just so you know, there are differences in this.
So can you do a question mark on that?
I believe so. And it doesn't give us anything. That's cool. Sometimes it helps put it in quotes. Like I said, I'm not an expert on regular expressions, okay? But they can be helpful. What they're usually I just use grep to find a certain word, and then you use a globbing pattern to say I want you to look inside all the .f90 files, okay, or .c files, or something like that. Okay, so that's that first bullet point. Then we have data streams. So in Linux, every program has 3 data streams, at least 3 connected to it by default. We have the standard in data stream, we have the standard out data stream, and we have the standard error data stream. So standard out is what you see on the terminal. Anything that gets output is being output to standard out. Okay, if there's an error one there for outputting the errors. You usually don't see those unless you have an error. But those generally show up on the terminal as well. Standard in is a little different, but it's basically anything you put after the command comes in through the standard in data stream. Okay, and generally you don't need to worry about that. The programming language that you're working with is going to take care of stuff like that for you. Okay, now the coolest part is this is really helpful if you're running a program and you want to save the output. You can use what they call, I forget what they call it, but it's the save to a file character. If I did it right, input file, and it's also the output. Oh, okay, fine. Hello. It was saying there's a recursive relationship. It was trying to grep through the output.txt and put it back into output.txt. So it was preventing that from happening. But if we open now output.txt, we see it spit out the line from the Adele file and put it into the output file. So that can be really handy, especially if you're running a program and you want to save the file. In fact, we'll probably be using that a lot with the CHPC clusters as well, because they actually do that by default. They redirect, is what they call it. They redirect the standard output to a file so you can look at your result, because you're not interactively running the program. You're telling the supercomputer, hey, I need you to run this program whenever you can. And so they save it to a file for you using a method similar to this. And then if we wanted to we can go the other way and use standard N. So we're actually going to take output.text and feed that into grep and say, I want you to grep through what I'm feeding you. Okay? And so it's telling us, oh, look, I found hello inside of there. Okay, so if you want to redirect standard error, instead you just use this to. So I noticed I forgot to mention the numbers. So standard N is given a designator of 0, standard out 1, standard error 2. And if you want to redirect a different one, you can do it by putting the number in front of the caret sign there. If you want to redirect standard error to standard out, there's a little idiom here that's useful. And then we come to piping. And piping is extremely useful. Piping is how we take all of our little building blocks and we put them together. Okay? So if I do, say, ls, okay, and I want to find a particular file. Now, this is kind of a dumb example, but let's say I want to list everything that starts with a D. Okay, well, it actually kind of does it for us already. But what we can do is we can take that result, we use the piping character, which is just this straight line, and we send that to grep. And we want to look for downloads. So what the piping character does, it takes the standard output from what's ever on the left and attaches it to the standard input of what's ever on the right. Okay? And that's all done by the terminal. And your program, has to be built to do that, but most Linux programs are built to do that. So you'll notice if we just did lsd, it gave us every single one. But then we wanted to filter those results down to specifically the downloads. And so the piping character can be really handy. And as it gets really complicated, you end up piping all these programs together. You can do some really cool things with it. Alrighty. Now, let's say you want to see what's going on. You want to know what's running on your computer. There's a program called top. And top lists what's going on. It lists the user, it lists RAM, and I'm not sure what all this stuff is, but you can see what's going on. And most importantly, you can get the process ID number. That's this first column here. At which point, if something is frozen, you can then kill it using the program called kill. Okay, so you say kill, and then you list the PID number, and it will try and kill that program nicely. However, if that doesn't work, you can do kill-9, which says kill it no matter what. Okay, and I'm not going to worry about that. That's complicated, but oops. So virtual consoles. So back in the olden days, Linux was nothing more than a big black screen, okay, before we had nice GUIs and stuff. And so those consoles, as they're called, are actually still running. And you can access them by saying Control-Alt-F2. So, for example, let's see if this works. Ta-da! Control-Alt-F2 pulls up the F2 console. F3 pulls up TTY3. It's a little small. F4, F5, F6, F7. Well, F7 didn't do much of anything. And F8 brings us back to the GUI console. The GUI itself is its own console. But if your GUI is ever frozen, you can do Control-Alt F2 and log in. Whoops. Yeah, that guy doesn't exist. Mint admin. There we go. And now we've logged in, and I can do top, and I can kill it from here. Whatever's freezing up the computer. So that's handy to know. Also, Control-C kills lots of things. So if you want to get out of something, Control-C is usually a good way to go. You can exit, and then we do Control-Alt F8 to pull back our GUI. Okay, foreground, background processes. So this is kind of a handy trick to know. If you want to run a program and it's going to run a long time and it's going to, hang up your terminal, you can actually run it in the background. So there's a program here called Sleep. I want everyone to count to 5 for me. Ready? Go. Okay. So Sleep is kind of a dumb. I don't even know why they have it, but Sleep 5 says sleep for 5 seconds. And you'll notice it hangs up my terminal. It doesn't let me, I can't do anything else. There it goes, okay. So there's a handy little trick if you want to run something in the background is you finish your command with an ampersand. And you'll see it runs in the background and it gives me my terminal back. Now, and it also gives me the PID number, 4178, or 5, that's a 5. And so let's do something a little more drastic, just so we can see. Oh, and it tells me, look, Sleep 5 finished. And so we can do top. We probably won't see sleep in here because it probably doesn't take much effort to do that. But if I want to bring it back, you can type foreground, FG. It brings that background process to the foreground. And now my terminal is hung up. Of course, I can just Control-C that and make it go away. Make it stop. So that's some handy stuff to know. Control-Z in a terminal will generally take your foreground process and flip it to the background. This is very confusing if you're using something like Vim. Okay, so let's make this big again. So let's say we're in Vim, we're typing yada yada yada. We want to undo. What do we all do in Windows? Control-Z. Well, thankfully, all it did is put a blue thingy there. In this case, there we go. Control-Z. You'll notice it tells me Vim has been stopped. It's been stopped and moved into the background. So it's technically not even running at the moment. So if you've ever run into that, just type foreground and it'll bring it back. Okay? Until you break your Control-Z habits. Okay. So, if you want to get new programs, I already showed this to you, sudo apt-get install programs. So whatever programs you want. The Linux flavors, the Debian, the Ubuntu, they have some massive repository somewhere with thousands upon thousands of programs. And this is how you install them. They're all free. They're all wonderful. If you don't know what you're looking for, then I suggest you download, do sudo apt-get install Synaptic. Synaptic is a package manager. Of course, they all come with package managers. So let's see, we go to menu, we look for software manager or Synaptic. Mint already comes with Synaptic because it's awesome. But this is Mint's default software manager. And you can search through it and find it. It's got pretty pictures and generally useful if you want to find games. The games on Linux are usually pretty lame. Not gonna lie. And it's taking forever to load, which is wonderful. So this is the Synaptic Package Manager. And if you don't know what you're looking for, say you want something with MPI, you can type MPI in the search box and it pulls up a list of everything that has MPI in there. So that's pretty handy. So if you want to set up your own Linux system and do the class on it, then you're going to need at least these right here. Build Essentials will get you your C, C++ compilers. If you want Fortran, you get GFortran. If you want MPI, you're going to need those. And optional programs that you're going to maybe want: CMake, Doxygen, Git, Mercurial, Valgrind, and Vim. Okay, now the very brief introduction to Bash scripting. So, anything you can type into a terminal can be placed into a script, which the terminal can then run. Bash scripting is actually a full-fledged programming language. It's kind of a sucky one, but it works. Everyone seems to be okay with it. So, for instance, let's just do this. Generally, you end with the extension .sh. It's not really necessary, but there you have it. And usually a bash script will start with this line here. Now, in bash scripting, the pound sign, it is not a hashtag, but the pound sign is a comment. But if the operating system will actually check for a pound sign exclamation point, which they call the shebang. I don't know why they call it the shebang, but they do. And then you give it a program, and that indicates to the operating system what program is supposed to run this script. You can do it for lots of things, actually. And the operating system will use that program to run it. But then we can type anything. You'll notice Vim even highlights the grep there. So if you ever don't want to have to remember a big long list of commands, you can put it into a script. You'll see I have blah.sh there now. Now, in order to run it, we actually have to have execute permissions. And if we look at blah, no one has execute permissions. So we have to do a chmod user, since we really only want us to do that, plus execute blah.sh. Now you'll notice the list command now highlights blah.sh nicely for us. And in order to execute it, all we have to do is type / and then the name. And you see it attempts to run it and doesn't do a very good job. Not really sure why that is. That's funny. Well, I feel sheepish now. Anyway, but that's the basic idea. And there's lots of tutorials on how to do bash scripting. And you probably won't need it that much. But if you want it, there you have it. Now the other thing is the path variable. So your terminal, it has what they call an environment. And this environment has environment variables. And path is one of them. Okay? And what the path is, it tells the operating system where to look for programs. So every time you type grep, it's going to say, okay, where is grep? Is it in user local sbin? Is it in user local bin? User bin? And lots of these things, okay? It's going to go look through these folders, find the program called grep, and run it. Which is why we cannot, if we just type this, it tells us command not found. So we tried to run a command, it didn't find it in the path, which is why we have to tell it that it is in the current folder. The dot stands for the current folder. And now it says, oh, you told me where it is, so now I can run it. It doesn't do a very good job running it. Not sure why, but we'll get back to that later. So, and that's basically to prevent accidents. It's a safety thing, is the way why that is. Variables, you can declare variables in your scripts, which is helpful if you want to use the same thing quite a few times. So all you have to do to declare a variable is say a word equals hello. So now we have a variable called word. And we can use that variable in here by putting that. And you notice Vim highlights it nicely for us. We can make a new one called, no, we'll call it something a little better. Okay, and so if we ever need to use those same things many times, we can do it this way in our script. And it should give us, nope, that's interesting. It did work though. Okay. Yeah, I have done this before, I promise. I don't know why it's working right now. Probably because I'm in front of people. Okay, last but not least, how are we actually going to log in to stuff? And we log in with the SSH. SSH stands for Secure Socket Layer or something like that. And it allows us to have remote access to other computers. So I have my lab computer on campus, and I can actually log into it, maybe. No, it's not going to let me. That's annoying. It might be the virtual machine thing. Oh, unless I typed it wrong. There we go. Okay. It's going to ask you if you want to continue connecting. You have to type the word yes and then give your password. And now I'm logged in. You'll notice I'm logged in as Oz. I had to specify who I was logging in as up here. And so SSH, PuTTY uses SSH if you're on a Windows machine. So that's how you're going to log into CHPC, which is University of Utah's cluster, or Resource Computing, which is our cluster. So we can exit out of there. I believe. And my password, this is just your password for everything else here at the university. What is my password? There we go. So now I'm logged into USU's cluster. Now, if you want to actually use USU's cluster, all you have to do is log in. And it'll set stuff up for you automatically. So we don't have to go through the whole getting a U number process here. Because we already did that. And I'll talk more about that later. Okay, so that's how you log into their stuff. We'll learn more about this tomorrow, but we should just be, this will be the address to log in. And then kind of a nifty little trick is if you look in here, we don't have, oh yes. So there's a .ssh folder, a hidden folder in which you can put your, oops, I used the wrong command. I want to go into it. If we look inside here, known host, don't touch that, okay? But we can make a config file. And there's some documentation online on how to do this, but if I wanted to add in my lab computer like that. Now I do this for the University of Utah because I don't want to remember my U number. So, and once we now have this config file, we can do SSH, and it will actually tab complete anything in that config file. And it will use my username. You'll notice I didn't have to type oz@platypus. And so all that's left for me to do is my password. So I do that for the University of Utah because I actually don't know what my U number is anymore because it's in the config file. So that's a handy little trick. And then the last thing we need to do is file transfers. You're going to have to be able to take your files and transfer them to the University of Utah's stuff so you can actually run things. And we do that through SFTP or SCP. I prefer SFTP. It stands for Secure File Transfer Protocol. And so oops, I shouldn't have done that. Let me blow this up again. Okay, so if we do SFTP to my computer, put in my password, okay, it's going to give me a little prompt. And it actually has quite a few of the normal commands. So this is my home directory on my computer in my lab. And if I wanted to put, oh gosh, what do we have? There we go. So I have blah.sh on this computer. I use the put command to transfer blah.sh from here to there. Okay, and there's an opposite one called get that we can get stuff with. So I don't even know what this is. So I just got that. Oh, ta-da, it's me. So that's how you're going to move stuff to and from your computers. Okay. And that is the end of that. And time is up. So thank you for coming to class, all 4 of you. And we'll stop there.